Good afternoon. My name is Nicholas Economides. I'm a professor at the Stern School of Business of New York University. I'm visiting professor at the Haas School of Business of UC Berkeley. And I'm also the founder and executive director of the NET Institute. The NET Institute, Networks, Electronic Commerce and Telecommunications Institute, is a focal point for research in network industries. Today, I'll be talking about an economics perspective on SDN and NFV. So we're talking about software-defined networking, S&D, and network functions virtualization, NFV. What these acronyms stand for is for moving functions from network hardware to software. So now software will execute network functions as applications, while hardware will become more homogeneous. What are the advantages of these changes? Well, the first advantage is adding flexibility. There will be more flexibility in network functions, and they will be easier to use. The second advantage is that at the software layer, there will be cheaper and easier innovation in network functions than before, as well as in administration. So that will be a significant benefit of this change. Additionally, because of easier innovation at the software layer, there is the possibility of more complex functionality at the software layer, or I would say at the edge. Finally, there are strong indications of higher scalability of NFV. So there will be additional possibilities of scaling the network up without incurring extra costs. So there are going to be significant cost savings, which are going to be mainly realized by cost reductions in hardware. Once the change has been made, we can have an adoption of homogeneous hardware, which is simpler and cheaper. And we know from the past of other examples in which changes that brought together cheaper hardware have been made and made a big difference. A good example is supercomputers. Supercomputers are very complicated, they're fine-tuned, and they're expensive. But people have found that they can create equal computing power by combining, through software, cheaper PCs and be as effective as supercomputers. So in doing that, one can achieve a 60% cheaper supercomputer, but it's not really a supercomputer, it's a combination of PCs. So that points to the direction of being able to create the same functionality through NFV with much cheaper and simpler hardware. So we're taking away costs, we have cost savings from hardware, from CapEx, and we're moving it into software, that is OpEx. When doing that, it's likely that we're going to have some savings. So the cost transfer is not going to be 100%, and we're going to realize overall savings in making that transition. Additionally, software innovation will be cheaper, and that will reduce the cost. And how can that be done? For example, it could be done by using open source software and have these extra cost reductions, or to have third world programmers work on the software and again reduce the costs of software. Additionally, software costs sometimes can be considered as part of CapEx. Also, other management functions, operations, etc., which were traditional OpEx, are simpler now through software, so OpEx may be reduced as well. So essentially what this slide says is that we're going to have significant costs in hardware, and we expect that in the transition to software, we're going to have significant cost savings. Now, it's important to have open APIs and interoperability, because we know that creates significant decreases in end-to-end costs. We have a striking example in PCs where the Intel Microsoft platform that allowed for interoperability resulted in at least 25% cheaper systems compared to the closed Apple platform in the 80s. So we know that open interoperability can really work to the advantage of consumers by cutting costs. Additionally, we can have the potential for easy and cheap upgrades that can create significant future benefits, but it's hard to quantify them at this stage. One type of savings that is there potentially as well is the possibility of sharing the network equipment by more than one telecommunications operator. So that can be very significant savings. It gets created by NFV, and we'll see if we're going to go in that direction. Now, on the disadvantages side of SND and NFV, there is a potential loss of performance as the specialized hardware becomes transformed, becomes changed by homogeneous hardware. Now, I expect that this loss of performance is going to be short-term because of expected innovation in software. So in summary, if we look at the short run, meaning 1-2 years, and look at the effects of NFV, we have the following positive effects. First, system flexibility. Second, cheaper, easier, and more innovation. Third, higher system scalability. Fourth, cost savings in hardware. On the negative side, we have the possible temporary loss of efficiency of the specialized hardware, which will be replaced. What about going further in time, going beyond the 2-year horizon? In the medium and the long run, we're going to see more entry in the telco arena because the threshold for entering has been reduced. So we're going to see new, pure software players, and we're going to also see new innovation at the edge. Both of these are reminiscent of two earlier revolutions in technology. First, the change brought by Microsoft to PCs, which created PCs, separated the hardware from the software, created a software-only company, Microsoft, in the late 70s, and created all kinds of technological change and innovation through the software revolution by making the innovation happen at the software level rather than the hardware level. A second revolution, and this is current, is innovation at the edge of the internet rather than at the center of early electronic networks. As you all know, in earlier electronic networks, we couldn't have significant innovation at the edge, but once we had the internet and we had simple protocols that allowed for high innovation at the edge, that created a tremendous revolution in technology and applications. So these two revolutions of the past point to the direction of a possible revolution when the changes that we're describing today may happen. How big are the benefits going to be? it is generally difficult to quantify the full benefits. But I expect the following. First, from the simpler hardware, I expect that at least 15% of the system cost will be saved just by going to simpler hardware and not away from specialized hardware. Second, there are going to be benefits from flexibility of the new administration. And these benefits I expect to be at least 5%. Third, there are going to be significant benefits from innovation in software, as well as entry of new rivals in this industry, pure software rivals. And these benefits will be very substantial, in my opinion, somewhere of the order of 10 to 50% of the system cost. So if you add these numbers up, the cumulative benefits are going to be somewhere between 30 and 70% of the present system cost. Now, of course, this is not a very rigorous analysis. It's a preliminary analysis, and we need to further investigate the full economic impact. But the numbers that I'm presenting are so substantial that say that it looks like a good idea that we should go forward in that direction. In the longer run, there is going to be a shift in the strategic focus to software at the edge. It is likely to cut costs, it scales gracefully, can be profitable quickly, innovation is much faster at the edge than at the core, and will likely drive investment outside the network infrastructure boundary. So I expect that we're going to see a very positive economic impact overall. In summary, NFV is potentially a radical, or I would say a revolutionary change. And it reminds me of two earlier revolutions in high technology. The first being the separation of hardware from software by Microsoft in the PCs, which resulted in a tremendous new ecosystem of software for PCs, and made a huge impact on the United States and world economy. The second revolution that this NFV reminds me of is the shift of innovation to the edge of the internet compared to the older electronic networks where everything was happening at the core. Now, we live through this, we are in the middle of it, and we know very well that this innovation at the edge has had a huge impact on the world, not only the high technology world, but the rest of the world as well. So, in summary, I think NFV has the potential for a very radical and revolutionary change. Thank you very much. And let me give you my email in case you might have any questions. It's in the front of the presentation. It's my last name, Economides, @stern.nyu.edu. So if you have any questions, feel free to write to me, and I'll be very happy to respond. Thank you. Thank you very much.